Welcome back from an ad break. So learners, we looked at the density, mass, and volume as our main idea. So after that, we looked at the density and the states of matter. We looked at the density of different materials. So now to recap other things that we did, we also used certain words throughout the lesson, words such as mass, volume, density, physical quantity, and immiscible liquids. So those were the terms that we used throughout the lesson to better explain the concept of density, mass, and volume. Right. What I need you to take away from this lesson is the following. That number one, when the mass increases, the density increases. So we're talking about the relationship between density, mass, and volume. So where is this coming from? When we have an equation of density is equals to mass over volume, we are saying when the density is increasing, the mass will also increase of the same substance. And then the second part says, when density increases, the volume decreases. So which means when the density increases, the volume, it is going to be decreasing. So the same thing is true about the decreasing in density and the decreasing in mass. So when density decreases, mass will also decrease. So those two things, they have that relationship that is corresponding to each other. And then when we're talking about the density and volume, when volume increases, density must decrease. So when one increases, the other one decreases. Also, two materials with the same volume, the material with a higher mass will be more dense. So when we are talking about two materials that have the same volume, the one that has a higher mass or the one that is more heavier is going to be said to be more dense or has a greater density. And particles are very small. We need to know that particles are very small, that we cannot be able to see them by our naked eye. And any small piece of matter has millions of particles. So any small piece of matter that we can think of or that we can see has millions and millions of particles within it. And remember that those particles are always in a constant motion. And because of that motion, those particles, they do not expand or they also do not compress. We said that we can compress gas particles. We are not really compressing the actual gas particles, but then we are rather decreasing the space between the gas particles. And then gas particles, or particles rather, they do not expand or compress. The particles, they either move away or they approach each other. So we're not compressing the actual particle, but then we are decreasing either the space or increasing the space between the particles. That's what we mean by when we are increasing or when we are compressing a certain substance. So now, I've answered a lot of questions. Now it's your turn to do the very same thing. My question for you today is, I want you to explain why substances expand when heated. Why do substances expand when they are heated? Now, until I see you next time, I hope you had as much fun as I did. Bye.